Welcome back everyone, I'm Dr. Andy Galpin and this is 25-Minute Physiology. Today we're talking all things endurance, conditioning, fatigue, whatever label you want to put on it. Now in previous videos, some 5-minute and some 55-minute biggers, we've talked about all these 6 different points you're seeing on the screen. All right, so in this particular video though, we're going to talk about number 1 and really number 2, which is how to design your programs, your workouts, or your training, whatever you want to call it, to optimize or improve your endurance. Now, but before we do that, I have to define what I mean by endurance, and I like to put them into a couple of different categories. All right, so that's what we're going to get into today. Thanks for sticking around, and let's have some fun. So you can see the actual definition of endurance down there. It doesn't particularly matter. In my mind, it's anything that makes you tired. And there's a bunch of different versions of that. So I like to put them in 3 broad categories. The first being muscular endurance, then high intensity, and then long duration endurance. And you can see a quick example on the screen, and I'll go through each one of these in more detail. Now, the reality of it is, I actually split high intensity up into multiple different categories, and you could split these up into infinite different ones. It just depends on how specific or detailed you want to be. So if you come from a background where you actually like to categorize them slightly different, it doesn't particularly matter. If that's the case, I would actually strongly encourage you to watch the long 55-minute physiology of endurance video, because in that I actually show how I don't really think about endurance training like this. I think about the physiological problem or the limiting factor performance, and then I program around that. But if that didn't make any sense to you at all, start with this particular video. Or even if that did make sense to you, you can probably gain a couple of things from this. And I almost guarantee you when we get to the muscular endurance, I can bring some things up that you're probably not doing very often in your training, or specifically, in the high intensity stuff, right? A lot of people are doing high intensity intervals, but there's a lot of mistakes that are being made in that realm. Okay, so a quick example of muscular endurance, it's several repetitions. You can see my friend Chris Moore here in the picture, and he's attempting to lift that car as many times as he possibly can. So that's a muscular endurance fact. He's going to be limited by the endurance in the muscle, the actual local exercising muscle. He won't be limited by his cardiovascular system or his pulmonary system or his blood flow or anything like that. High intensity is a little bit different. Now you're talking more like circuit training. You can see Coach McGee there, Alex, and CPT doing a circuit and things like that. You all know different examples of high intensity interval training, and that's going to be limited by things that are different, not necessarily always just the exercising muscle itself. It could now start working into systematic difficulties. And then at the other end of the spectrum, Amelia there, long duration endurance stuff, not limited by muscular endurance. Good example here, a 1-mile run is not muscular endurance. That's slightly different, right? A long duration endurance in my mind is when you're covering big distances or big time intervals fairly consistently. There could be small intervals within them, like you would see in a Spartan race or something like that, but the entire duration is longer, right? It's much more extended. So to go into each one of them, a little more detail there. Muscular endurance in my mind is how many times you can do given a certain activity, a certain amount of times. So this typically ends up being medium to low percentage of your 1 rep max. This is one of the 2 technical ways we can define intensity. So intensity either based on percentage of your VO2 max or your heart rate, or in this particular case, percentage of your 1 rep max. And so because you're doing muscular endurance multiple times, it ends up having to be medium to low rep. Muscular endurance would not be something like I did 95% for 2, took a break, and I did that a whole bunch of times. That is a special type of strength endurance, which is a little bit different. So for now, think muscular endurance is the classic, how many push-ups can you do in a minute? Something like this. How that's different from high intensity is those can be at medium to high percentages of your 1 rep max, but typically we differentiate this here and we talk about this as being a percentage of your VO2 max or your heart rate. So it's no longer about the weight per se, where muscular endurance typically is. Now we're talking cardiovascular pulmonary challenge. So it's typically, it can be high weight, can be low weight, really kind of depends. Long duration, of course, is low to very low, oftentimes sub-body weight, i.e. swimming, right? You're actually moving less than your body weight, cycling, rowing, things like that, right? Now, don't be confused here. I'm not saying any one of these is less difficult or more difficult than another, more awesome, more fatiguing, anything like that. They're just high or low percentages of your 1 rep max. So how I want to get into this video, and the way I like to teach, is to teach 2 things, concepts and methods. If you hit the proper concepts I'm getting at here, the methods can be almost limitless. And so I will give you some methods as examples, but I really want to get to the concepts, and that's where I'll spend the most amount of time on. So let's jump into some of these concepts. The first one we're going to talk about is that muscular endurance. So some basic concepts here. This can be programmed in terms of the choice of exercise via single or easy small movement exercises or multi-joint complex movements, either one. Example, a single joint movement, you can do muscular endurance of your triceps, no problem. If for whatever reason you've decided that's an issue you need to work on, you can do single leg hamstring, or it could be abdominal muscular endurance, or you could pick complex exercises, burpees, lunges, twists, jumps, whatever they happen to be. All right, so either one of these is fine in terms of choosing the exercise, no problem. You're going to want to typically do somewhere between 3 to 5-ish sets, but this, of course, I say ish because it really depends on the athlete, the goal, the training cycle, what type of movements you're doing, what are you doing tomorrow, yesterday, etc. But typically 3 to 5 is a very standard place to start. Now it's going to happen somewhere between the 12 to 100 repetition per set range, but it's mostly like the 12 to 25-ish, okay? If we start talking past that now, you're probably moving into a position where you're no longer being limited by the actual local muscle, and again, it's more of a pulmonary, cardiovascular, blood issue. It also happens to typically be very light because of that. And so this is where this is the key thing that differentiates muscular endurance, is it's some repetition range, 30, 40, 50 reps. Again, the key example here, how many push-ups can you do in a minute? I don't know, 30, 40, 60, 80, something. It's not 3,000. It will never be, right? It's going to be limited by that. It's not also 5. That's going to be limited by strength, not the endurance of the muscle per se, right? And there's some gray areas, absolutely. I give you ish, 12 to 100-ish, right? So there's a lot of gray there, but that's typically what we're talking about for muscular endurance. So because of that, it has a pretty wide range of the percent intensity you can use. 80 might be pretty damn high. It's really tough to do 12 repetitions or more at 80%, but it is possible. Some people can do it. I have, and it's terror. It's absolute terror. But mostly you're talking 50, 60% at most of your maximum. You're going to want to take somewhere between 30 seconds and 180 seconds of rest in between your set. But again, this really, really depends. You can go a little bit shorter. Just don't compromise the intensity of the rep range. You have some wiggle room on those things. So, fast or slow speed. So these could be things like, again, as many push-ups as you can do in a minute, and you're going to crank those out as fast as you can, but at some duration halfway in or something, you're going to really slow down. Or it could be intentionally slow. There's no reason you can't work on muscular endurance by doing really slow repetitions, and you might only get 5 reps in a minute. Or you might do something like isometric for that matter. It could be a wall sit, and you're trying to hold a wall sit for 40 seconds if that's tough, or a plank position. A plank is a muscular endurance task. Very good way to think of it. Some people can only hold a side plank, say, for 30 seconds, and that's a challenge. And that's a very slow movement. So examples of methods, I've already described a couple. Sprints are okay here, but not typically a great example of muscular endurance. Sled, push a sled, do some rowing, any of the other exercises I've mentioned. Repetitions to failure is a great scheme if you've ever done that, right? So you set a certain load and you don't even have a rep range you're hitting. It's as many as you can until the muscle fails. Fantastic concept. Circuits can be good there. Just be careful. We don't go into other ranges of training, but if you did something like, 20 bodyweight squats and 20 push-ups and 20 pull-ups, that's going to work on muscular endurance, assuming you don't do it for a very, very long time. There's a touch of it there. As I mentioned, isometrics, where you're not moving at all, holding a position. So you could hold a bicep curl, hold a half squat, hold a lunge, hold a wall squat, hold a plank, hold an overhead press or push-up position, whatever you want it to be. Virtually anything here you want that you can do maximally without a huge eccentric load. And this is the thing that's very, very important for all of our endurance, fatigue, or conditioning training, and it's very different than, say, our strength, speed, power, or even hypertrophy training. With endurance, we typically want to be very careful, and we want to minimize the amount of eccentric loading. This is because that type of training or that type of muscular contraction causes a lot more muscular damage. It doesn't mean you can't do it. It just means you need to be very aware and conscious of how you implement these things. A good example, if you have an athlete or an individual who's not extremely trained or hasn't done any eccentric stuff in a long time, and you have them do even 3 or 4 or 5 reps of eccentric, say squatting or jumping. Jumping is a good one, right? You have to absorb the land. It's not the jump off that is the problem. It's the eccentric load when you land. Well, if somebody hasn't jumped in 15 years and you have them do 3 sets of 5 jumps, they were probably going to wake up tomorrow extremely sore. Now imagine you had them do that for a circuit, 3 or 4 rounds of sets of 20. They're going to be brutalized the next day. You're going to be absolutely train wrecked for weeks at a time. Especially in an athlete, you might be gone for 3, 4, 5 days a week. A non-athlete, that might be several weeks. And so it's a real big problem. I'm not saying at all you can't do these. I'm just saying you have to really understand when you start implementing eccentric exercises or movements for a whole bunch of repetitions. Right? Real problem. You can take advantage of easing the eccentric load, and this is something like a box squat. Okay? So if you jump and land on a box, the amount of eccentric loading is severely minimized. Now, I'm still not a huge fan of using box squats for muscular endurance for most people. If you're in a sport or an activity which requires that, fine. But the risk-reward ratio is pretty for box jumps for conditioning purposes. But that's one thing that can be possible. Notice with rowing and dragging a sled, all those things have very minimal eccentric action. It's push, push, push. It's not a land absorb. If you run often, running is fine. If you don't run often, this is going to be a real big problem, especially if you do some like agility work and you try to do an agility circuit for conditioning and it involves a lot of stopping and going back the other way. That's a really big eccentric load, and that's going to be a problem. Right? So just be very careful. Isometrics seem to be just fine. Concentric is just fine. A little eccentric, okay. A whole bunch of eccentric, it's a real big problem. All right, so again, to recap, not against it. Just make sure you really think through who you're giving it to and what amounts, and are they prepared for it? Do they move well in those positions, etc. And because of this, I typically am going to recommend for all of these training modalities in the endurance realm, very little, if any, implementation of weightlifting movements. And by weightlifting, I mean very specifically Olympic weightlifting. So no snatches or clean and jerks, or no variations of those. No power jerks, no power cleans, no hang cleans, for more than 12 or so repetitions. Now, even after 8 repetitions, it gets sort of questionable. If you work in a facility or an environment that does this, and you're trained and you move well, and this is a normal part of your routine, no problem. It can certainly be done. I know plenty of people who do very high repetition Olympic weightlifting movements. No issue. I typically, though, as a general statement, don't think it's a good risk-reward. Same thing with plyometrics. Think of plyometrics as jumping and landing. All right, so leaping, bounding, all this stuff, you just have to be very careful because of, with the plyos, the eccentric component, and with the weightlifting movements, again, the whole point of muscular endurance, high intensity stuff, or long duration is to induce fatigue. And so now you're asking an athlete to go overhead, or an individual to get in a compromised position already with extreme fatigue. Can certainly be done. Again, don't misinterpret there, but let's just think about it. My personal philosophy is, unless you're working with an individual that does that or needs to do that in the competition, there's probably other ways we can achieve our endurance without those particular movements. So again, just think, okay? Use your best judgment with who you're using it with. Are they prepared? What are the pros and cons? What are the risk reward to those things? Now, what you'll notice here is for the high intensity, I'm actually going to split it up into 2 separate categories. Okay, category 1 with high intensity is what I call anaerobic endurance, so AN. This is not, I repeat, is not something like your max power. So when we talk about your maximal anaerobic capacity or your maximal anaerobic endurance, I'm not talking about your max sprint speed or your max clean and jerk. We're talking about a fatigue issue, right? So if we're talking maximal anaerobic endurance, remember, it's still an endurance issue. So something has to be taken to fatigue, but it's the anaerobic side of the equation. This is almost exclusively with complex movements. I don't know if I've ever seen anybody do an anaerobic endurance bout with a single joint exercise or a bicep curl or something like that. Again, 3 to 12-ish sets really depends on all the stuff we've talked about, but this is what differentiates them. I no longer at this point program repetition ranges because it doesn't really make sense. This is better thought of as a work to rest ratio, and I think it should swing anywhere from like a 3 to 1 work to rest, all the way to a 1 to 5. Now, most of you, I'm sure, have done something like this, and you probably have done the classic 20 on, 15 off, or 30 on, 30 off, sprint the straightaways, walk the corner type of thing, right? Yeah, you've done this? Yeah, I'm sure. It's awesome. Well, most people tend to stick to that 1-to-1 work-to-rest ratio, but the total duration is very short. This is what makes it anaerobic conditioning. So you can't do anaerobic endurance work or conditioning work for more than, say, 2 or 3 minutes of an individual go without taking a break. If you do it longer than that, that's a separate endurance thing, which we'll talk about in just a second. Okay, but what most people fail to do is manipulate that work-to-rest ratio very often. So a 3-to-1 would be something like 30 seconds as hard as you can, but now 10 seconds off. Ooh, it's brutal. But everything has a pro and a con. Okay, if we go the other end of the spectrum, like a 1-to-3, this would be the same 30 seconds of work, but now you're taking 90 seconds of rest. Right, so the time domain doesn't matter, it's the ratio. Or you can go with the 1-to-5, so 10 seconds of work, 50 seconds off, whatever. Well, these two different types of anaerobic conditioning give you very different adaptation. If you keep a very high work, very low rest ratio, the quality of the next round goes down, right? You imagine 30 seconds as hard as you can on a bike, on one of those upper body, lower body bikes, right? And you get 10 seconds off. You're not even close to recover for the next 30 seconds. What that does is help you train at trying to work through extreme fatigue, right? You're not going to get an improved performance there because you're just going to survive. And that's good, but the downside is you're not going to enhance peak performance, right? The other end of the spectrum, which is now, say, 20 seconds of work and a minute and a half rest, well, the accumulated fatigue from that 20 seconds of work is going to be long dissipated in that 150 seconds. And so you're going to be able to train yourself to work up to a higher peak again. That 20 seconds, you're going to be really putting out big power outputs or covering far distance or doing a lot of good work. So if you need to practice increasing the work you can get done in a short time domain, give yourself more rest. It's still plenty fatiguing, and it's actually fatiguing in a different way because the work you do in that same, say, 20-second interval is so much more than the work you do in the other 20-second interval when you only had 10 seconds of rest. All right, I'll give you a tangible number. Imagine you're going on a rower, and I'll make a number up. It doesn't make sense at all, but it'll help you if you've never rowed. Maybe in 20 seconds, you can make it 100 meters. And then when I give you 10 seconds of rest, the next time you go for that 20 seconds, instead of getting 100 meters, you go 90. And then the next time, it's more like 50. And you just fall off the earth, right? You just tank, and you're just barely moving by the third, fourth, fifth round. Well, the other way, where I give you that 20 seconds, boom, and you get 100, and I give you a minute and a half off, next time you go again, you might be 97. You might be back at 100. You might be able to stay at 100, 3, 4, 5, 6 rounds in. Or by the 7th, 8th round, you might only be down to 95, or 5th round, or whatever happens to be. And so now, the 4th round of the first style, you're doing half the amount of distance. But the 4th round of the other style, you may be at 97% of your max distance. The downside of that style, though, with the long rest intervals, you're not necessarily working on recovery, right? You're not necessarily working on dealing with a really high fatigue level, right? And so both of them have their place, but they're still both going to help you with your maximal anaerobic endurance. So my recommendation, your homework, if you will, is if you do intervals, well, first of all, if you don't do intervals, shame on you, angry professor face here. But when you do them, change it. Change your work pace a little bit. Change the duration. If you always do 30 seconds, go to 45. Oh, 45 is a mother. Oh, it's a breaking point, right? Or go 10 seconds. You've always done 30, you've always done 30, you've always done 45, 60 seconds. Go 15-second goes. And really push the power output on those 50-second goes. It's going to be different, and the metabolic demands are actually slightly different. The energy and the physiology is different. Okay, but regardless of whatever you're doing, whatever work-to-rest ratio you use for anaerobic conditioning or anaerobic endurance, it's going to have to be, by definition, greater than your VO2 max. And this is normal physiology. You'll have to read up on VO2 max if that confuses you, but not greater than your heart rate, max heart rate, of course, but greater than your VO2 max, which means it's anaerobic. And you're going to maximize speed on all your repetitions throughout, but depending on your work-rest ratio, you may, in fact, slow down quite a bit. In terms of the method you use, same kind of idea that we talked about, muscular endurance. Sprints are great here now, fantastic. Uphill sprints are great. Sleds, rowing, all amazing. Anything you can do maximally without a huge eccentric component because, again, the rep range gets very, very, very high. If you want to integrate some weightlifting or plyos into this a little bit, okay, but just be careful. Right? So now that we understand anaerobic conditioning, let's move on to aerobic conditioning or aerobic endurance. And did you see the slide change already? Aha, I gotcha. You were sleeping on me. Don't sleep. No sleeping. I caught you. Glutes on, core on, no sleeping. Okay, let me flash back. Anaerobic, aerobic. Anaerobic, aerobic. You notice the subtle difference here? Same, basically identical, but with a difference in work to rest. The major difference between anaerobic and aerobic is the time domain. So you can still do intervals, you can still be 1-to-1 or 2-to-1 or 1-to-2 or something like that. But now, instead of this being 2 or 3 minutes at the maximum, you're probably looking at 3 to 15 minutes or so per round. A very classic track and field cross-country example are called 1-mile repeats. If you've never done them, you have some other homework to do. They are fantastic. You can do the same thing on a bike or a row and just make the equivalent change in distance. But something that takes you 7, 8 minutes, 6 minutes, somewhere in that range, however long it takes you, take that exact amount of rest and do it again. That's a 1-to-1 ratio, right? You could do slightly different. You could do a 5-minute, whatever, how fast, most different distances you can cover in 5 minutes. Take 5 minutes off and repeat that. Or take 10 minutes off, and that'd be a 1-to-2, right? Oh, that's a fantastic workout. They're long. Brian McKenzie, Power, Speed, Endurance. His book is fantastic and describes how you can use this style of training to accomplish the miles you need to accomplish to do something like a marathon. So instead of just jogging for 10 straight miles, do something where you do 800-meter repeats and accumulate 7 miles. Much more effective way of training for a lot of reasons. I shouldn't say more effective, but it's read Power, Speed, Endurance, okay? Very, very, very good. Follow that website. And so this is maximal anaerobic condition. The difference here now is it is something that takes you at some point or in the finale to your VO2 max-ish. You can also think of this as maximum heart rate, pretty close. But maximal aerobic endurance is your ability to get up to that maximal aerobic endurance, which is our definition basically of VO2 max. It is not long duration endurance. Maximal aerobic capacity is not your ability to jog for 30 minutes. It is how much work can you do in that 8 to 12, 15 minute time domain. That's it. So play with your numbers there. Do 3 minutes on, 1 minute off, repeat 8 minutes on, 16 off. You get it, right? Give you some different examples of there. And of course, choose whatever method you like. So if we combine those two together in my 351 class, I typically think about this, kind of just talk about muscular endurance, high intensity, and long duration. So I combine the anaerobic and aerobic into high intensity, right? So what you're seeing here for high intensity is kind of a combination of that anaerobic and aerobic. So they end up being work to rest ratios there. The rep ranges are kind of goofy and things kind of combine over there, right? So I gave you some other examples, 1 mile repeats, walk, jogs, etc., etc. All right, so now let's finish up this whole 25-minute series. I think we're getting pretty close to that 25-minute time domain, depending on how close I am, and finish up with long duration endurance. This is by definition typically 1 set or 1 repetition. It is continuous. There can be slight undulations, right? Change tempo a little bit, go up and down, but it's roughly continuous, so it doesn't have to be literally steady state. It's submaximal because you're doing it for a long duration of time. And now we're talking anything typically longer than 12 to 15 minutes. As I mentioned before, there's huge gray area with all this. Don't get too bogged up in, well, it was 11:59, so then just think about it more conceptually. Major difference here being you want to emphasize low speeds and typically efficiency, because the goal of long duration endurance is not necessarily time to completion, it's distance traveled or time to work, right? So a good example here, I used to be involved in an undergraduate class where it was called a marathon class. And so you signed up the first day, you ran as far as you could. Most people made it 5 miles or so. And in order to get an A in the class, at the end, you had to run a complete marathon. Now, it didn't matter that you improved your time, your speed, or anything like that. It just, you had to be able to travel further distance without breaking down and stopping. And by the end of the class, almost every person completed the entire 26 miles. VO2 maxes didn't change. All right, their VO2 max did not go up at all. They just improved their ability to cover long distance. And that's important, that's good, that's healthy. I like it too, that's crazy, it's impressive, it's difficult, it's fun. but that is not necessarily directly improving your VO2 max or your maximal aerobic endurance, just improving your ability to do more continuous work. So that's how I like to break these things up. Obstacle course racing, cycling, all this stuff. Physical activity can be long duration of work. Gardening, working, whatever, etc. Or anything you can do maximally for that time domain. So that being said, that wraps up point number 1 and 2. If you want to hear more about why we get tired, how we make cellular energy, what is that VO2 max exactly, and why we breathe, you're going to have to tune in to some of the other videos. But that's it for now. I really appreciate the support. If you stumbled upon this video or somebody shared it, go ahead and subscribe below, or I don't know, however the hell YouTube works. Please subscribe, like, and share. If you have just enjoyed this video, I would really appreciate it if you shared it around. You can see all my websites and other places to learn and follow along. But hey, hopefully you learned something now, and go get some fatigue done. Go get some challenging stuff done. We'll see you next time.